Good evening, ladies and gentlemen. Welcome back once again to the CERCA monthly expert talk for the month of August. Now, this month we are pleased to present Professor Bahni Ray, who is an assistant professor in the Department of Mechanical Engineering at IIT Delhi, and who will be speaking about various mitigation techniques to combat air pollution. Professor Bahni had her BTech and MTech from the Indian Institute of Technology, Kharagpur, and PhD from the Indian Institute of Technology, Kanpur. She is currently an assistant professor in the Department of Mechanical Engineering at IIT Delhi since 2017. From 2013 till 2015, Professor Bahni worked as a postdoctoral fellow in mechanical engineering in the City College of City University, New York. And from 2012 till 2013, she worked as a postdoctoral fellow in the Department of Mechanical Engineering at Johns Hopkins University, US. Her areas of interest are multi-phase flow, physics of fluids, microfluidics, computational fluid dynamics, stability analysis, and traffic flow. I would now like to invite and welcome Professor Bahni to deliver her talk. The talk would be of 30 minutes, followed by 15 minutes approximately of a question and answer session. Over to Professor Bahni.
Thank you. Thank you, Mr. Hemant.
Okay.
Yeah, it's a great platform for me today to present this work. So let me share my screen. Hello. Good afternoon, everyone. So as the title suggests, today I am going to speak on mitigation techniques to combat air pollution. So the title itself carries a long term, which means the mitigation. And this is something which we are struggling everywhere in the world. So the main enemy which we're looking into now is the air pollutants, which could be particle pollutants, which could be gaseous pollutants. And we need to know what are the shortcomings or what are the ways we could mitigate that. So whenever we want to tackle some enemy, what do we see? We should see what are the shortcomings of that enemy. So the same way we will see that what are the things we are looking into the air pollutants and how we are tackling them. So first to tackle them, we should know the characteristic of this air pollutions. So let me just go through some initial slides, which will be on exactly what air pollution means. And this is anyway known to most of you, but I will very quickly go through it just to know who the enemy is, whom we are tackling today. Okay, so intensity of the air pollution, when we look into, we first see what is the source from which these pollutants are coming. So is it a mobile source? Is it an indoor? Is it an outdoor? So there are different range of sources from which pollutants can come. Depending on that, there could be different types. Then the most important part, once it has come out, is the dispersion rate. So how quickly it is dispersing in the atmosphere or in the entire medium where we are looking into. And what is the residence time? So the last 2 points are equally important as the first two, because depending on how quickly it is dispersing and how long it is staying in the atmosphere, then only we could figure out how we will tackle it. So if we look into the second circle which I made is how we are tackling that. It could be the available resources which we have, which I will show you today, the list of resources which we have. What is the ambient condition? So here, the atmospheric people come into picture, like we should know what is the temperature, humidity, wind condition, what is the location, all those things to import that particular resource. What is the concerned space which is getting affected? Is it a school area? Is it inside a room? Is it an office? Or is it an open traffic space? And who are the concerned people? So all these factors will be noted when you think about the mitigation technique. So quickly I will go on the sources, or again, as I said, I'm calling them the enemies which we are tackling. So first we are looking into the gases. So if you look into the gases, most of them are mainly consisting of carbon monoxide or carbon dioxide, which again, the maximum part is from the transportation or combustion of fuels. And then there are other like manufacturing and other factors, which I will not go in details in these slides. Then there is the NOx, where again, the main contribution is from the transportation. We have SO2, which is coming from transportation as well as some other electricity and heat productions. And we have volatile organic compounds. Here we have combination of transportation, and if you see there is something like residential input or oil and natural gas. So in indoors, for example, we have a lot of sources where we are getting VOC as the pollutant. And there is a new enemy now for us, which is the HFC or the hydrofluorocarbons, where this is why I'm saying it's the most bad enemy, because here it is coming from the refrigeration or the air conditioning, without which we cannot live nowadays. So we cannot avoid having this. And if you say it is about 47% of the entire chart, which gives this HFC. So apart from this, we have particles, which we called the PMs in short form. So here in this chart, we may have again seen this kind of chart. Why I kept it again here? It's because if you look into the sources, the green ones are which are from nature, which we cannot avoid, and the red are which are man-made. And that's something to think of, that we are making the pollutants and we are now deciding or thinking of ways how to remove them. So that's a real concern for all the researchers nowadays. And if you can see here, when we're talking about PM10, so it actually consists of particles which are coming from fly ash, it could be smoke, it could be diesel engine exhaust, it could be some bacteria, virus, all those ranges. So regarding the size, most of the papers, or whenever I look into the size, we compare with the hair, human hair, which is about 50 to 70 micron, and we say that we are looking into much, much less sizes, like PM10, which is around 7 times less than this, PM2.5 and PM0.1. So PM0.1 is something again which are in the range of ultra-fine particles. So they're called the coarser particle, the finer, and the ultra-fine, depending on the size. So here I kept this spider silk or spider web, which also we could see through our naked eyes. And it is about 2.5 to 4 micron. So that's the range which we are looking into for the fine particles, and lesser than that are the ultra-fine particles. So this I said from where we are getting this. PM10, the larger one, are mainly from the dust, and some ranges are from the waste burning or industries, and PM2.5 are mainly from byproduct of the combustion. So that's the scenario, and that's the enemies we looked into. And again, what are the chemical property of those? So when we again think of device, how to mitigate that, you should know that what is the chemical property, so that chemically also you could tackle them. So we know the size, that is the physical property. We should know the chemical property as well. So if you see some names, I will not read on. So it could be potassium, calcium, it could be of zinc. So there is range of elements which could be present in the particles. So again, indoor pollution again have the similar condition, and which we mostly do not talk about that much, because mostly when we say about the outdoor pollution, that looks much, and we feel that okay, we should do something about so much pollution outside in Delhi, mainly in the winter. But indoor pollution is equally bad, or you could say sometimes worse than the outdoor condition. So there are these airborne particles like again smoke, fiber, hair, pollen. There could be volatile compounds, which is the maximum in indoor cases, mainly due to the paints, the furniture, office equipments. There could be odors and those kind of things as well. And then there is microbes. So just quickly, I will show some pictures just to give an idea. Like when you've seen your room in your entire building, in your bathroom, you could have molds, odors, microbes. In your kitchen, you could have again fuel, oils, so some kind of gases are there. Even in your car, you have all this range of gases and volatile compounds, microbes, and all this range. So if I list them out, they are like asbestos and lead, which are something new here in the indoor pollution, if you see. And then we have the other ranges, and there are radon, again, which are mainly seen in case of if there are cracks in the floor. So there are some new kind of compounds, if you see here, in place of indoor pollution as well. So what is the solution? So there are two ways we could do it. First is control at the source end. And this is what we can all try to do. Even if we are not a physicist or a scientist, everyone could try that. And this range of solutions were given by the IIT Kanpur report in 2016 when they got the CPCB project. They said that if you have, say, for cooking, you should use LPG. You should not use coal or wood. If you are doing some biomass burning, you should cover the char. You should use that as a raw material than burning it. If you are using a vehicle, you should target for vehicles which are either electric or hybrid. So there are different range of options which any normal man, common man could do. And then there is another set of solution which is making some device or using some device. So either you develop a new intervention, and when you develop that, you have to access its cost, or you have to access how it is effective in that particular situation, and then design a program to optimally deploy that set, again in a cost-effective manner. So that's the two ways which we could go. So the left portion, that is the control at the user end, is the one. The right portion is the one which I will talk about today. Control at the source end is something which is again a different zone and which I will not talk about in this presentation. Okay, so I will move on a little faster now. So this is the entire introduction, and now I'm going towards the different ways through which we could do. So first, I'm talking about the water spray, or sometimes called the waste dust rubber or particle absorption. So they're the same thing of different names. So this is something which we see mostly in cities, that whenever there is pollution, we spray water. And this is something which we see that spray, and the lower one is the water cannon, which is called, and it produces much smaller size. You can say ultra fine size of drops. And then on the right hand side, this is an industrial water scrubber, where once the pollutant is going in, there is multiple sprays which cleans the air which is going in, and then the clean gas is coming out. So the factors on which it depends on the droplet size, velocity, the pressure at which the gas is being taken. And again, in case of outdoor pollution, so if you see in the industry, it is something which is going on indoor. But the two pictures which I gave is outdoor. So in the outdoor case, another factor which comes into picture is induced air flow. It means if there is wind blowing, and if the flow of the spray itself is so much that it is removing the particles from that zone instead of capturing them, then that is a disadvantage. So those things should be taken care of, that are we inducing some air flow on the medium. So then there are different ways by which this capture happens, and why I kept this because that some of this is the work which we are doing in our lab. So if you have very small particles, it will have Brownian motion, very small, like it could be nano size. It will just move randomly and go towards the droplet. If you have larger size, it will just go directly, like the inertial impaction, it will go directly to the droplet, or it will follow a streamline. So streamlines are something which when an object or a drop moves, it creates some kind of flow path. So that's called the streamline. So sometimes it follows a streamline and then the particle goes to the droplet. Or it could be due to electroscavenging. So where you have charged droplet and you charge the particle by induction or by some other means, and then you attract them. And this is the topic which in our lab we are working on some PhD projects, so that we devise some electro spray. And why it is beneficial from the current sprays is that it can tackle minute sizes and also some particles which are very hard to capture. But if you could capture through the opposite charge attraction, that would be better. Okay, so now the different types of sprays which are existing are like the hollow cone. If you see the image itself, it's a hollow. It's a full cone, the flat fan, and depending on the type of spray, one could be used for widely dispersed system, or used for airborne dust control. The second kind of categorization that the air is taken on through a pipe and then passed through a tank of water. It means that the air or the air bubble carries particle, it removes the particle into the water, and then clean air goes out. So that's the aeration process. And through this, this is one of the picture I've taken from a patent. So this is the way some people do. We can devise the method of mitigation. Again, depending on the sieve size, the height of the liquid column, the type of the flow, how much the air compression power should be, everything are factor to be noted here. And the most common is the air filter or the fabric bag. So this is again a common mitigation technique in industry where you have many bags or fabrics where the air is passed and it's like a filter which collects the dust and the clean air goes out. So here again the factors are that in this case actually in fabric bag it is a dry particle which is mainly used, and how you're arranging them, how you are cleaning them, those are the different factors. And pressure drop is something which is very important to note here, because when more and more particles get captured, there is a filtered cake which forms on the surface. So it becomes a thick layer of that particle. And then the pressure drop is more and you need more power to run it. So you have to clean it regularly or to change it to make the mitigation to continue. So here are some pictures which I've shown for large scale for the outdoor pollution case. So this is what was built in China, where again there were a range of multiple filters in this tower, and the air was sucked in from below and it was moving through the filter layers and clean air was going at the top. This is what we have in Delhi, the smoke tower in Delhi, which could clean about 1000 cubic meter of air within 1 kilometer radius per second. And they have equipped with 40 fans and 5000 air filters. So you could see how much of power is needed here and how many filters we have used here. And then we have again a Vayu unit in Delhi as well, which again is the method of filter which is used. Here again, similar to the droplet and particle interaction, the method is quite similar in a way, like if it is bigger particle, it directly impacts the filter. If it is a smaller particle, it has Brownian diffusion and it reaches the filter by random motion. And one good thing about this filter technique is you could also tackle gases or particles at high temperature. So not exactly gases here. Gases will come up in some other method. If we talk about the particles only. So I'm talking about hot air which is moving. So if you see the below, this is the temperature. And in the y-axis is the PM or the particle concentration. So for metallurgic and cement plants, the temperature is quite high. And for that, there are ceramic filters with which you could capture this kind of pollutants. And then indoor pollutants, if you talk about, we have the air purifier. And I picked up one of the example here just because to show you how advanced we reached in this air pollution filter business. So here there are layers of filters. First, the pre-filter, which tackles the larger particles. Then the carbon filter, which takes care of the odor. Then we have the HEPA filter, the one which is the main filter used in most of the air filtration systems, which takes care of the micron-sized particles. Here, the new thing which you could see is the titanium oxide filters, which takes care of the neutralizers and molecules, and combine the UV. There is an extra UV ray as well, which takes care of the bacteria and viruses. And then the last stages, they have the negative ions, which again cleans the dust and contaminants. So they have 5 to 6 stages of purification, which goes on in this air purifier. So a lot of work has been done in air purification, and the disadvantage which I could say here is that you have to clean this or you have to change these filters regularly when it gets clogged. Okay, so the range of other methods by which you could mitigate are coming under collectors. So I will directly go to them. So this is again in industrial use where you have used for larger particles, which again particles greater than 20 micrometer, and due to gravity, when the air is going through it, due to weight of the particle, it goes down through the hoppers and clean air comes out. Then we have cyclone, which is again very much used nowadays. Here, it's not due to only the weight, there's a centripetal force as well, because it's a cone shaped and the particle or the air moves in a spiral motion and we capture particles less than 20 micrometer as well. So these are called the cyclone separator, the cyclone way of cleaning the air. And most common is electrostatic precipitator, that also most of you have heard of, where you use again electrodes to capture the particle. So you put in gas inside and you charge the particle gets charged, an opposite charge and it gets attracted towards the electrode. So this is the collector electrode, and ultrafine particles could be captured through this. And there are two kinds of ESP nowadays, dry and wet, because you need to clean that electrode which collected the particles. So first is you collect, and the next stage you have to think of how to remove those particles. Otherwise, the instrument will not be in use for longer. So either for dry ESP, you just flap it with some hammer kind of thing, which is already inbuilt in the ESPs, or you could clean it with water, which is a wet ESP. So both of that exist nowadays in industry. Now we are looking into the gas. So from particles, we are slowly moving towards the gas pollutants now. So if you look into the wet gas scrubber, or sometimes called gas observer. So when you are saying wet, it means we are using water. So when we are saying about water, it means that it could have water and the flow of the air in the opposite direction. So here is the water spray and the gas is moving in the opposite direction and it is cleaning up and the clean air is going out. Or you could have it in the same direction, or the co-flow kind of scrubbing where the spray and the air is going in the same direction. There could be some modification to this where you could use again a Venturi kind of geometry, which helps to collect more finer particles, because particles as well as gas both here, because when it is going through this shape, it has this spiral motion again, and it can collect more of the impure gas and the pollutants. The next category for gases is adsorption. So I talked about absorption and now it is adsorption. So there are two different terms used here, which in chemical engineering, they know a lot about this. So as a mechanical engineer myself, I had to learn the difference a little bit. And now we are working on this adsorption phenomenon as well in our group, just started it. So what exactly it is, that if you have an absorber bed, it could be kind of a porous structure, it could be collection of small granules, which adsorb the gas either physically or chemically. So it could have one layer of adsorption, which is like a chemisorption, or it could have a multi-layer of adsorption. So it is an external kind of phenomena which happens. And in case of absorption, it is a phenomena where you completely dissolve the thing. So that's the basic difference. And it is most effective at high concentration of the gas and at low temperature. So this is a typical kind of geometry if you see how it works. So there's absorber bed, and the most common kind of absorber or absorbent which we see are activated carbon, silica gel, then polymer-based materials, zeolite. So those are again quite costly and as well as not much abundant in nature. So that's the part of research which goes on in adsorption, that what kind of material could be suitable for doing this kind of adsorption phenomenon. Then the next category is condenser. So this part is more like what mechanical people do when we teach heat transfer, heat and mass transfer. So we talk about condensation. It means you have some hot gas and you condense it into liquid. So the same technique is used here. If you have a polluted air, again, we are talking about the gas pollutant. So if you have that polluted gas which is going in, it converts, there's a phase change, and it collects the gas into liquid, and then the clean air goes out. Okay, and you may say now that why the entire air is not getting condensed. So the temperature is set in a way that it could condense only those impurities which needs to be collected. Okay, so there are again different types. It could be spray type, it could be shell and tube type. And then the other part which is the combustion. So this is a totally chemical process and where we actually burn the gas. We actually come to the combustion of the gas. Though we are saying that burning is not good, we create more byproducts, more poisonous gases. But again, this technique is used a lot for gases which are more harmful. And if you burn it, it could convert it into either CO2, water, and some inorganic gases which are less harmful. Okay, so we are happy with something better than nothing. So that's the kind of situation here. So this is the thermal or catalytic incinerator or thermal oxidizer, which is called. This is the category which goes on that. Now the next category is the biological treatment, which I would say is one of the techniques which I think should go a long way, because if you look into this, here we are not using something artificial. It's a natural way of doing it. And there are three categories here again. Biofilter, where the filter again is made up of something biological. It could be wood chips or something. And there could be biotrickling, where you have water trickling through that filter, or it could be something where you have bioreactor. So there are three categories into it, and it mostly tackles VOCs or odorous molecules in the gases. So it cannot tackle all kind of gas. Again, that's a shortcoming. It could mainly tackle the gases which have odors or the presence of VOCs. But again, it could go a long way, I think. And this is very interesting way, like that was where the bacteria was. So if I go to the previous slide, what actually biological thing happening here is, so when I'm saying you have some materials like some wood rust or something, but in that the bacteria are growing and that actually taking the gases, that actually are eating the gases, poisonous gases. So the similar way, the bubble thing which I showed in the last few slides, here what in Ayrshire they did, and in London also they built something like this, some park, where they have tubes full of algae. And then these small bubbles or small round shapes which you are seeing are like some pump, where the kid or somebody could just stand in that and air will push on. So this is similar to the link here, where the air is getting pushed and it is going through these tubes, multiple tubes full with algae. And the bubbles which are going, they're getting cleaned by the algae, and then the clean air is coming out. So that's another way of biological treatment on the impure gas, which again is not done in large scale. It is in small scale, which is being used nowadays. This technique is again another technique where we are again using something we're getting from nature, that is plant. So this is something which again is close to my heart, because this is again natural. We do not need to depend on something else, but you need to know about the plant structure. What are the type of plants, what are the type of their leaves, their stems, and how much capable they are. So if you look into indoor nowadays in big buildings, you will see in the corporate buildings, you will see this kind of things that they're now in the outside. In road also we see that some walls are covered with this kind of plants. But I don't know about outdoor, but indoor it's very, very essential and very, very important that how it works and how it cleans the air. And then I'm talking about the urban tree, which is again a factor which is important and which actually the environmental or the civil people work on this part, which is mainly on outdoor. So I'm giving one example here. So say if you look into the bottom picture, there are three houses of the same height and you have their car parkings there. So there is some pollutant which has been created here due to any reason, but they cannot circulate because of the movement of the air is just above it and there is no way of circulation inside. And now if you look into the top figure, where one of the building is high, other building is lower, and you have trees in between, and that helps in the circulation. So whatever air is coming in, it circulates inside, it takes in the dirty air, puts in the clean air, and helps in the mixing of the air and cleans the air. So that is again comes into city planning kind of thing, where the trees are helpful, the way you are building the city is helpful. Okay, and this could again tackle, though we think that these are just plants, how much they could do, but they could tackle particle matters, volatile compounds, inorganic compounds, POPs, HMs, and all those kind of particles which are harmful and which could be used in indoor pollution remedying. And these pictures I just took, this is from one of the paper in 2019, and this work, this phytoremediation, this topic is not that old. It may be around 10 years old, from which people are working a lot on this. But the first time it was said by NASA that plants could reduce pollution, but there was not much work done on it. But in last 10 to 20 years, a lot of work has been done on this. This is one of the paper where they devised such thing. And in India, we have a very startup company, You Breathe Life, which built a device like this, where they are saying that the roots are helping in the cleaning, but they have a HEPA filter layer also. So they're doing double cleaning in this. And they're taking care of different kind of trees. So for example, let's say the peace lily, there could be dragon plants. So all kind of indoor plants. What if you're like indoor plants, you may know some names. So if those kind of plants could be used. But again, not only roots, the leaves, the twigs, wherever there is some hairy structure, they help in collection of particles and all those ingredients. And this is the last technique which while preparing the slides, I just got this, and it is a very interesting technique which is being used. Here, if you see, it's called the photocatalytic or smoke-eating pavement and building. So it means we are mixing titanium oxide, TiO2, with the cement, and that actually helps to capture the NOx in the atmosphere in presence of, again, sunlight. So there will be photocatalytic. So sunlight or the temperature should be sufficient so that the NOx could be captured. And when you pour water in it, or if it rains, say, it converts this NOx to NO3, which could be removed. So this entire thing has been implemented as well in some countries as a test case. Again, it's not a fully fledged mitigation technique. It has been used as a test case. And they saw at least 50 to 60% of NOx could be reduced on the road. And even if you use it on the buildings, then again, it will be multiplied by that. So this is one of the great technique which civil people have devised. Okay, so I will not go through this slides. It will be quite boring. So we looked into different categories like collection of the particles, converting the particles or gases to something which is usable, using natural means, using chemical waste, and then using electric field, different kind of field, electric field. And there are UV as well, as I said, we are using ultraviolet rays as well nowadays. So all the categories have both the advantage and disadvantage. So this again is a big list. And as you know that whenever we see some problem, we have to devise some route to solve it. Obviously, there will be both advantages and disadvantages, but we have to play that what is more important to us. But we have a list now and we could work on it. And now I will gradually end this talk. So I think I have finished my time as well. I will give a food for thought. Now say you have a confined chamber and you have an unconfined space like outdoor. So I'm giving you two cases, like for confined chamber, if you have a spray nozzle which removes the dust per unit of water, directly increases with nozzle operating pressure. So if you keep on increasing the pressure, the dust removal rate will increase for the confined chamber. Because as you increase the pressure, the droplet size decreases and it will be more and more applicable to capture the small particle. For unconfined space, as the number of spray nozzles and water pressure increased, for unconfined space, the dust capture effectiveness per gallon of water is reduced due to dilution from spray-induced airflow. So that's the thing which I said. It should be taken care that are you capturing or are you pushing the air which is close to you, because you are putting the force so high that you are actually pushing the air away from you. So that's the problem in case of unconfined. And the second thing is the residence time. So why I kept this as a food for thought is this. So on Sunday, I was like all of you, I was watching on TV, the Noida Twin Tower demolition. And when I was seeing this, first thing came to my mind is what is going to be the pollution. So that is the first thing which came to my mind, because the rest of the things obviously that they have taken care of, but pollution is something which is the aftermath. It will continue for months. So they have used this kind of sensors and about 20 monitoring stations. They calculated the PM's values, the AQI values. They have used cannons, they have used sprays. So cannons, as I said, have fine, ultra-fine size of drops. Spray have little larger size and they do not go to a larger height. It is in the ground level cleaning. So that's good. And now if you look into some property of the particle, how the residence time changes. So if you look into this SO2, NO2, ammonia, PM10, they remain for hours. So they will remain in the atmosphere hours and then they will settle down. So that's the thing which they had captured within that time. And then if you look into the next zone like CO2, CH4, and then CF6, all these ranges, and then PM2.5, they remain for days, weeks, and they can stay for long and long. So that's the thing which we need to think more. So are we tackling only for some particular time, or our device could tackle for a more time and it is more efficient. And these are the two images I have taken from again internet from the PM10 and PM2.5 in Noida. So if you see on 28th, so this is the line which was the larger on 28th, which when the demolition happened, the PM10 was higher that day, and it's obvious that the detector detected this. And then on the same day, if you look into 28th, the PM 2.5 was not that much. But after 2 days, like now today is 31st, yesterday it was 30, so red one. So yesterday's one, it is the red. So it is again, the PM 2.5 is quite large. So you do not know, is it that or it may be something else? But again, some correlation we could get from here that the PM 2.5 is something which we could not capture from the way which they did by using spray or cannons. So devices should be thought of for outside, and for indoor devices will be different, and that should be what we should think. And already I gave you a list of the devices which are existing. You could combine them, you could look into the advantages, disadvantages of each of them and think of what could be the best. So I will end this. Thank you for your attention, and I will take up the questions. Thank you.
Thank you, Professor Ray, for the very insightful presentation and sharing your research experience. So now moving to our Q&A session. So our first question is from Dr. Mohit Kumar. The question says, are there any studies to evaluate the impact of smoke towers in reducing air pollution in Delhi?
So the question is whether the smoke tower is helpful or not, right?
Is there any studies to evaluate the impact of smoke towers in reducing the pollution?
Yeah, reducing the pollution by smoke towers, yes, as I showed in the slides, we have smoke towers in Delhi. Two kinds till now, and multiple of them are being put now in different places, in Connaught Place and different places now it is there. So it has started, I think, 3 years back. So let me go to that slide and show that picture. Yeah, yes. So the smoke tower, which is shown here, it is the first on in Connaught Place, I think. Yeah. So here they said that this is the one which was given, but then if you see the entire report, they said around in Delhi itself, around 200 more such smoke towers should be implemented to take care of the entire Delhi pollution. So now I think second or third has been implemented. And then there is this Vayu, which takes care about 500 square meters. So in this, they're trying to make it much more bigger now. They're increasing the size so that more air could be taken in. And then again, you cannot do anything with a single smoke tower, a single Vayu at a particular place. You have to have multiple of them. And again, the question which I said, that when you devise, you should think where you are deploying it. You have to make an entire program of deployment as well. So how much area it is covering and up to what range it is covering, and then only you could see the beneficiary of this. Otherwise, you cannot actually feel that something is actually happening. Yeah.
Our next question is from Keyusha. The question says, what is the economics cost of outdoor air scrubbing using smoke towers or other solutions?
See, the main economics, I think, I mean, maybe the expense you were saying about. So for the smoke tower, which we have, it's the filter. As I said, the HEPA filter. So the HEPA filter, and nowadays some groups who are working on filters, they made nano filters also. So that's the one which is the most expensive. So you have to change it regularly whenever it is getting saturated with the dust. You cannot just clean it and put it on. You have to just change it. So there are again techniques whether you could reuse it. So, but nowadays what people do, they have to actually change the HEPA filter again and again to work on it. So that's the part which is the most expensive one. And the second part is, if you see there here, they have used 40 fans. So this fan power, if you look at the size of this fan, they're huge fans and the power needed to work. So that's the other expense which goes on this, that how much power you are taking to regulate this fan because you are sucking in the air and giving out the clean air. So an interesting thing in this particular one in China, which they made was, they had a different system. They had something which has a material which actually gets heated, like something you could say you could use a solar panel or something, which actually helped the surface to get hot, and then it actually sucked it automatically, cold air outside automatically. So there was fan also inside, but the power needed was less than if you only use electric power. That's more, but if you use some other way of sucking air, it actually could reduce the times as well. Yeah.
Our next question is regarding the twin tower demolition. As you have already mentioned in your presentation, so the question is, the smoke guns which were used to control that air pollution on that day, can these be used to strategically control air pollution in Delhi?
No, that's the food for thought which I gave today. So as I said, indoor and outdoor, so you have to take care of that. Are you pushing the air away from you, or you are actually capturing? So when I'm saying this, these are fine droplets. So the fine droplets have two things. So droplets could be so small that it could evaporate very quickly. If the temperature is high, it will evaporate rather than capturing the particle. And it could, if it is not evaporating, then good, it will capture particles, it will fall down. But again, it will fall only if the gravitational pull is more. So the droplet will actually combine with particle, combine with multiple droplets. It will become a little bigger. It will have some size so that it could fall due to gravity. So that's the thought process that goes on when we use spray or cannons. But the other factor is, if it is coming out with very much force, there is turbulence created on the air, and the still air which was there, it is getting disturbed. And maybe by forcing the spray, you are actually removing the area away from which you are capturing. So these factors needs to be taken care, and I feel what the way which we are working, as I said, in our group we are working on spray. So one of the technique which could be used is similar to this, where you could intake the air from outside rather than spraying water outside, take the air inside, and instead of having layer of filters, you could have sprays like water scrubbing in industry, as you saw. In the same way, you could scrub the air and you could take out the clean air. But again, it's my own feeling, which I feel there would be obviously some effect, but those factors are also there. If you use just the cannons and multiple cannons also, if you use, that may not be that much beneficial. You have to have those estimates and those calculations done.
Okay, ma'am. Ma'am, our next question is from Deepak Kumar. His question says, if I understand correctly, you have mentioned that dust particles are charged. Can you elaborate a little more on this? Like example, is the charge preferentially of one sign?
Okay, yeah, very good question. So yes, we are working on this, and it's interesting that particles, yeah, let me go to that slide. Yeah, so particles by itself have some charge. That's by nature. You cannot have completely neutral particles. It carries some charge that has been seen. And it could be again both charge, it could be positive or negative. But whatever may be the charge, whenever you are using a spray, it is in your hand what kind of droplet you are giving out. Are you giving a positive droplet, positive charge droplet, or negative charge droplet? So when the particle comes close to that, it will induce, as I'm saying, that mechanism is again quite complex, that how that induction happens. It could induce the charge to that particle and it could attract it. And there are multiple physics involved in this. But yes, both the charges exist in particles, not a single. It could have any kind of charge.
Okay, ma'am. Our next question is from Ravi Kaushik. His question says, won't electrospraying increase humidity? Because as increase in humidity will require more energy to be cooled.
Okay, so when you are saying increasing humidity, it's not about this electrospray. Any kind of spray, any kind of mist cannon, whatever we say, it increases humidity, true. And increasing humidity may not be a major factor than the pollutant capturing. So that's the thought which scientists put on when they used water as a tool. But yes, that could be another factor. As I said, you have to look into on what particular location you are using that particular instrument. If that place doesn't have that much capability, if the humidity is already high, then you may not use that particular remedy. But yes, humidity will increase. But as I said, it's not the main enemy. Our main enemy is the particle which we are trying to capture.
So, ma'am, our next question is from Karan Rao. His question says, India does not have norms for indoor ozone, which is harmful. As you mentioned, ionizing filters, which produces ozone. Curious to know if the damage by PM is worse off than harm by ozone gas. Any studies on this and your thoughts?
Yeah. Yes, studies are quite less on indoor pollution itself. That's the main thing. So when we look into indoor pollution, we know that there is all these compounds, and the main remedy most of the time we talk about is filters, air filters. So, or air purifiers. But again, yes, ozone and PM has equal kind of impact. And if I just show you that particular slide where we have shown the different kind of products which are coming out in household. So here if you see that ozone, which is actually happens for higher temperature when the VOC connects with NOx. So that's the way ozone comes in outdoor pollution. But in indoor pollution, the ozone is not much talked about. It's a VOC which is much talked about, and the other asbestos lead, all these are talked about. But yes, this could be another factor which could be looked into, but not much study has been done in it.
Next question is, which controls technology you think more satisfactory for outdoor air pollution?
Yeah, it's a very tricky question and nobody knows which is the best. So as I said, the list of things, list of interventions which are already there. So the best way could be, which I think which is close to my heart, was the phytoremediation, or the way the plantation, all those things are working. Because in that, at least you have multiple advantages. But again, that could be for a large tree to grow, it is a long time to have that. But again, filter has their own advantages, disadvantages. The spray has their own advantages, disadvantages. So there is not a single answer to this question. That's the main thing. I do not have a single answer to outdoor pollution. But what I will suggest that rather than outdoor, yes, good outdoor pollution should be tackled. But along with outdoor, indoor pollution, where you are staying most of your time, you should take care of that as well. Because the different kind of diseases which are happening nowadays is not because we are staying a lot outside, but we are staying a lot of the time inside. So that's the main which could be tackled, and for that devices could be made. Lot of devices exist, like the whatever this air bubble technique, the micro bubble technique, all those techniques which are already there could be used for indoor. For outdoor, those are the factor of scalability comes into picture, whether that could be in that scale can we make it. So, and whether how much area it could cover. So those things are really very, very vast calculations, which needs a lot of minds to work on. But if you have a small room, you know the area of your room, you could devise any kind of indoor solution quite faster. But for outdoor, answer is again not sure. Yeah.
So, ma'am, this is the last question. Does the use of air filters are known to effectively reduce the chemical composition, like carcinogenic metals, ions, etc., beside reducing the particle concentration levels? Are there studies related to that?
Yeah, filters, again, so mainly the filters which take care of the particles, those are mainly existing. But again, filters are nothing but porous structure. So for carcinogenic materials, or if you talk about carcinogenic gases or materials, so there are existing filters which are there, and people are again working on that as well. It's something which still is a working thing, but yes, there are existing filters on that. But as I'm saying, it's not the HEPA filter. It may be some other kind of filter. HEPA filter is mainly for ultrafine particles. So filters, as I'm saying, porous structure, there are other kind of filters, other kind of porous structures which could take care of those gases or particles.
Okay, thank you, ma'am, for answering all the questions. Now moving to the next formal vote of thanks for this session. I, on behalf of CERCA, want to extend my sincere thanks to Professor Ray for having accepted our invitation to deliver this expert talk, and it was real pleasure and honor to host you as our expert speaker this month. And I also want to thank all the participants representing from different sectors who took time off for attending this talk and making this session interactive through this Q&A session. Thank you once again. And we will announce our next scheduled talk via email and social media handles soon. Thank you so much.
Thank you. Thanks for a great talk.
Thank you. Thank you very much for this platform, for sharing my thought. Thank you.